The first part of question 8 in this C2 paper is solving a trig equation. And a couple of key details to see before we start working on the answers is it says to solve the equation between 0 and pi, which means that we're going to be working in radians. And it says giving your answers in terms of pi. So for this, what we would do is instead of finding it into degrees and changing it to radians, I would just put my calculator straight into radians mode. Now you can see that there's a sine and a cos there, and that should hopefully make you realize that we're going to be using one of the identities that we've learnt in C2, which is that sine theta over cos theta is equal to tan theta. And even though that's 3 theta, it doesn't really make much of a difference. Whatever you put for theta, so sine 3 theta over cos 3 theta is going to be equal to tan 3 theta. So with the equation we have at the moment, the first thing I would do is move the cos over to the other side, or sorry, root 3 cos 3 theta to the other side. So we'll end up with sine of 3 theta is equal to root 3 cos of 3 theta. Then divide both sides by cos, so dividing the left hand side by cos and dividing the right hand side by cos 3 theta, I meant to say, sorry. So as I've written beforehand, sine 3 theta over cos 3 theta is going to be equal to tan 3 theta. And, well, cos 3 theta divided by cos 3 theta is going to be 1. So we're left with tan 3 theta equals root 3. The important thing to remember here is that we're trying to find out solutions for theta. We're not trying to find solutions for 3 theta. So when we do the inverse tan of this function here, we're going to end up with 3 theta equals, but at the end of it, we want our answer to be theta equals. So what I'm going to do is change the range. So instead of it being between 0 and pi for theta, I'm now just going to change it to the range for 3 theta, which is going to be 3 lots of pi. So now when I solve for my solutions of tan 3 theta, I'm actually just going to end up with 3 theta equals, typing it into our calculator, we'll end up with pi over 3. Another solution from that, remember the tan graph repeats itself every 180 or every pi. So adding pi onto that, we're going to get 4 pi over 3. Add another pi to that because now we're trying to get it between 0 and 3 theta. So adding that on again, we're going to end up with 7 pi over 3. Remember, we want to keep our answers in terms of pi, so make sure that your solutions are in terms of pi. They're the 3 that are within our range. So now what I'm going to do is divide everything to 3. So we end up with theta equals pi over 9, 4 pi over 9, and 7 pi over 9. And you'll see that all of these solutions are between our original bound 0 to pi, and that's as far as you go from there. One thing I will say is a common mistake which can that you will originally find out the first solution. So let's say in this case 3 pi would be pi over 3. What people tend to do sometimes is they'll find out what the solution they got in the calculator, which was this. They'll then divide everything by 3 theta, sorry, divide everything by 3. So then they'll get pi over 9, and they'll use this value here to find out the other solutions, which will obviously be wrong because, well, because I've told you it's going to be wrong. People, you may have ended up will see answers such as 10 pi over 9 and then 19 pi over 9, because what they've done is they've added pi on every single time from this value. So this is wrong. Please do not do that. Find all of your solutions for 3 pi to begin with, and then that should help you get the right answer. 8, part 2, part A is a rearranging equation. We're trying to find cos x in terms of k. Now, the first thing to remember here is that we want to actually have cos x as our subject, not k. So our final solution should be cos x equals something. Now, obviously, what we want to do here is look at the function that we have to begin with, or the equation that we have to begin with, and we have here a sine squared x. Now, thinking about our original identities, we know that sine squared x can be written in the form of 1 minus cos squared x. So let's just go and substitute that in for there now. So we will get 4 bracket 1 minus cos squared x plus cos x equals 4 minus k. Expanding the bracket, we'll end up at 4 minus cos 4 cos squared x, rookie error there, plus cos x is equal to 4 minus k. Now hopefully you'll see that we've got a cos squared x and we have a cos x here, which sort of looks like we're getting towards a quadratic equation. So if we bring everything over to one side, we'll end up with, so taking the 4 minus k over to the left hand side, we're going to end up with minus 4 cos squared x plus cos x. Taking that 4 over to the other side is going to cancel out the 4's, adding the k, so plus k equals 0. Personally, I don't like it when a cos squared or x squared function is, or term is negative, so I'm going to times everything by minus 1, which means we're left with 4 cos squared x minus cos x minus k equals 0. Now, just for the moment, if I say that cos x is equal to y, so we're going to substitute in so we can sort of see a quadratic equation. Just going to say that 4y squared minus y minus k is equal to 0. Now, what we actually have here is a quadratic equation. We can't factorize this as it is unless you're, absolutely fantastic at factorizing. You're going to end up either having to use the completing the square method or the quadratic equation, where a equals 4, b equals minus 1, and c equals minus k. So once you plug it into the quadratic formula, you will get y equals 1 plus or minus the squared root of 16k plus 1 all over 8. Remembering, of course, that cos x equals y, so we can substitute that back in, and our final answer will be cos of x is equal to 1 plus or minus the squared root of 16k plus 1 all over 8. Part B follows on quite nicely from Part A. It says when k is 3, find the values for x in the range of 0 to 360. So in the same question earlier, we were working in radians. This time we're going to be working in degrees. So make sure that your calculator is in degrees mode. For Part A, we already worked out that cos of x is equal to 1 plus or minus root 16k plus 1 all divided by 8. And we're being told now that k equals 3. So substituting k into the equation that we worked out earlier, we're going to get cos of x is equal to 1 plus or minus the squared root of, 49 over 8. So we're going to end up with two solutions here, cos of x equaling 1 and cos of x also equaling minus 6 over 8. So I've written down, first of all, the value for when cos of x equals 1. So taking the inverse cos of 1, we're going to end up with 0. And you might think to write 360, but just be careful. Look at the range that we have here. It's more than or equal to 0, but less than 360. So 360 is not a solution in our range. Working on a second answer, we can say that x is inverse cos of minus 6 over 8, which putting into your calculator, you should get a solution of 138.6. Now, depending on whether you use the graph or the cast method, you should be able to work out the other solution. Remember, it's values that we're looking for. So generally speaking, you should end up with, well, with questions like this, 4, but because 360 isn't a solution, we should end up with 3 in total. So just drawing the cast diagram, let's see a ST in that order. I'm now going to draw the angle for 138.6 degrees, which, if that's 90 degrees, that takes it all over there. So we're saying that that angle there is 138.6, reflecting it in this line here. We're going to get another line here, meaning that angle here is 138.6. So finding our solutions, we're going to get one solution here. So from 0 to this line here, which is 138.6, which we already know, we've written that one down already. And the other solution starting from 0, going across to this line here, which is therefore going to be 360 minus 138.6, giving us another solution of 221.4, which means the values that you are looking for are, or the values that they want are 0, 138.6, and 221.4. Thank you for watching this video. I hope you found it useful, and good luck in whichever exam you're going to be taking, and your future and your life.